Okay, let's consider the question on the board. They are asked to find the derivative of this function using the product rule. You can see that both function has three parts, and these three parts, they are multiplying each other. Okay, let's start with the first question. F of x is equals to x squared plus 2x multiplied by e raised to the power of x squared multiplied by ln x. I'm very sure you are part of our previous class on how to differentiate a natural log. If you missed the class, kindly check the playlist logarithmic differentiation and watch those classes, okay? Because we are still going to be using it here. If you missed our classes on the basic rule, you understand? Just check the playlist on this channel and watch those videos, okay? It's simple, okay? Now, how do we find the derivative of this function? Don't forget, I told you, if you are given a function that has three parts, and these three parts are multiplying each other, you can use the product rule to differentiate the function. All you have to do is that differentiate the term individually and keep others constant. You understand? So in this case, let us identify our u, v, and w. U is the first part. So here, u is what? X squared plus 2x. And v is the second part. V is e raised to the power of x squared. W is the third part, which is ln x. Okay? Now, we need the derivative of u, we need the derivative of v, and we need the derivative of w as well. So, the derivative of u is equals to 2x plus 2. The derivative of v is equals to 2x in x squared. The derivative of w is what? 1 over x. Okay? Now, having differentiated the three terms, we can now use the product rule formula for three parts. You understand what I'm saying? This has three parts. The three parts are this, and this. All you have to do is that just take the derivative first. Having done that, then you go back to this rule and simplify it. You understand? Okay? Now, with respect to this rule, derivative of fx will be equals to derivative of u is what? 2x plus 2. 2x plus 2 multiplied by, just open the big bracket, multiplied by v and w. V is what? In x squared, multiplied by in x squared, multiplied by ln x. You can see? Then plus u. U is what? X squared. X squared plus 2x multiplied by derivative of v. Derivative of v is 2x in x squared. 2x in x squared multiplied by w, that is what? 1 over x multiplied by 1 over, okay, multiplied by w. W is ln x, multiplied by ln x, okay? Plus, now, we have u. For the third part, we are going to keep u and v constant. That is, we are not going to differentiate u and v, but we are going to differentiate w, okay? So, u is what? X squared plus 2x. X squared plus 2x multiplied by v. V is in x squared multiply derivative of w. Derivative of w is 1 over x. So I'm going to have multiply by 1 over x, multiply by 1 over x. Okay? I'm very sure you understood what I did here. What I do, this is what I did. I just follow this formula, okay? I differentiate u, keep v and w constant. U, v derivative, w. U, v, w derivative. Now, having gotten to this point, we can factorize, you understand? The reason why I want to factorize is because in an attempt to help us to simplify the answer, okay? So here, I'm going to have the derivative of fx is equals to, now, factorize in x squared, because in x squared is common to the three brackets. So I'm going to have in x squared, open the big bracket, 2x plus 2 ln x, okay, plus x squared plus 2x multiplied by 2x ln x plus x squared plus 2x multiplied by 1 over x. Do you understand? Okay. Now, we can open this bracket. See, we can open this bracket using this 2x. So I'm going to have f of x is equals to nx squared multiplied by ln x into bracket 2x plus 2 plus now ln x into bracket 2x times x squared, that is what? 2x raised to the power of 3. 2x times 2x, that is what? Plus 4x squared. Okay? Plus now 1 over x that we have here. I'm going to have x squared plus 2x multiplied by 1 over x, or x raised to the power of negative 1 is still the same. Okay? Now, I'm just trying to simplify the answer as much as possible, okay? In x squared into bracket ln x, I'm just trying to simplify the answer as much as possible, okay? Don't just be patient, okay? Now, ln x is common to both of these, so let us factorize it out. I'm going to have open the second bracket 2x plus 2 plus 2x raised to the power of 3 plus 4x raised to the power of 2. Okay, close the big bracket, then plus x squared plus 2x multiplied with 1 over x. Okay, so you can stop at this. You understand? You see, when it comes to differential calculus, you must know how to simplify your answer. Okay, so some people they can just stop here, because some people can stop here. You understand? Actually, they got the answer as well, but you must know how to simplify your answer to the best version. Okay, so the derivative of fx is equals to x squared plus 2x multiplied by n x squared multiplied by ln x is that. Okay, so let's proceed to the second question. We are asked to differentiate sine x cos x tan x. Okay, fx is equals to f of x is equals to sine x cos x tan x. Okay, identify your u, v, and w. U is the first part, v is the second part, and w is the third part. Yeah, differentiate each. The u is cos x, the v is minus sine x, and derivative of w is what? Sec square x. Okay, now the next step is to substitute all these values into this formula. So the derivative of fx is equals to derivative of u, that is cos x, open the bracket, cos x multiplied by derivative of derivative of u multiplied by vw. V is cos x and w is what? Tan x. Okay, plus u is what? Sin x multiplied by u multiplied by derivative of v. Derivative of v is what? Minus sin x, and w is what? Tan x. Okay, close the bracket, plus u is what? Sin x. So I'm going to have sin x, and v is what? V is cos x. Then derivative of w, that is sec square x. Sec square x. Okay, now the next step is that let's look at the term that we can add together. Okay, the derivative of f of x is what? Cos x tan x, that is cos square x tan x, plus open the bracket negative sine square x tan x. Okay, plus sine x cos x sec square x. Funny. Sine x cos x sec square x. Okay, so the derivative of f of x is, now you can factorize tan. Okay, let's proceed. Cos square x tan x. Now this positive and negative sign can open. I'm going to have minus sine square x tan x plus sine x cos x sec square x. Okay, now from this point, what is common to both and to all the terms? To these two, tan x is common, so we can simplify it as this. Tan x, for the first part now, okay, tan x into bracket cos square x minus sine square x plus sine x cos x sec square x. Okay, so you can leave your answer like this, and if it is factorizable, you can proceed to factorize as well. Okay, so that's all.